Hi, I'm Bodie from Bodie Knows, and this is episode 2 of the Engineer's Review series on the Carbide 3D Shapeoko 5 Pro. So for those of you who don't know me, 9 to 5, I am a mechanical design engineer. I've worked at various large manufacturing companies, designing equipment kind of similar to this, with ball screws, linear rails, various motion components, so I have a pretty good idea on what it takes to design a machine like this in the best way, and make sure that it lasts, that you get things set up properly, etc. 5 to 9, I'm down here in my basement making all sorts of different things. I'm really obsessed with RC airplanes. I do 3D printing, CNC routering, all sorts of DIY construction. I'm not sponsored in any way, although if you want to sponsor me, please let me know. I'd gladly take it. And a brief overview of this video, I'm going to talk about why I got this machine, some of the pros, cons, upgrades I've done, and then a cutting demo at the end that hopefully can show you how to push the machine to where I think I've found the limits. So on that note, the first pro I want to go over is the construction of the machine itself, and it's a big pro. So for me, any sort of hokey drive system with belts or V-wheels, anything like that was just going to be a non-starter, and this machine doesn't have any. So it has 15 millimeter linear rails on the X axis, same thing for the Z axis, and then the Y axis as well. They're behind these extrusions, which I like. They're a bit guarded. The ball screws on all three axes are 15 or 16 millimeters. I'm not exactly sure which. And the great feature with the ball screws is Carbide has their own wiper seal on them, along with like a nut and a spring on the outside. And so far, those have done a pretty good job of keeping debris out. Debris with ball screws is kind of an Achilles heel. If you get debris in there, they're going to wear out prematurely, and when you're routering, you're going to generate a ton of debris. A major pro is the construction of the parts themselves of the machine. So all of the aluminum parts that make up the machine are billet machined. So this HDZ plate, for example, it's a raw plate of aluminum, same with the back plate. Many of the mounting plates that hold all the extrusions together are also machined aluminum, and there's no nuts on the entire machine. It's all tapped holes all around, and the hardware is proper. It's socket head cap screws and button head cap screws, which is the correct way to do it. There are alignment features on all of the machine parts where necessary so that you can get everything square and positioned relative to each other properly, and that's exactly how I would have designed this machine if I were doing it myself, so I really like that that was done. It also makes assembly pretty easy. There's actually fairly little assembly that you have to do, which is a huge difference compared to the millwright. Having no nuts makes putting everything together fairly easy. You don't have to be holding a nut in one hand and a screw in the other and dealing with a bunch of different size tools and screwing around with that. So assembly was great. Cable management, both in and outside of the E-chains, is set up pretty well. So there's 4 E-chains, 2 on the X-axis. I kind of like how these 2 are dueling here back and forth, and then 1 on each of the Y-axes. They have the correct 180-degree bend, and when they move, that end moves as it's supposed to, and the wire, all the bend in the wires happens only in the E-chain. That's how it's supposed to be set up. Outside of the E-chains, the custom cable harnesses are routed properly, cut to the correct lengths, and they're really easy to put together. So overall, I'm really happy that there's no loose cords or extra wire that needs to be wound up and zip tied. It's all pretty well thought out, and I was pretty impressed with that. Lastly, for the machine construction, the spindle mounts are very well done. So they're designed and made well. They're billet machined aluminum, which is exactly how they should be. This is for a 65 millimeter or a trim router. It came with it. You get a different spindle mount for the 80 millimeter spindle, but they look exactly the same. They also have a nice dovetail mount here if you wanted to add some sort of accessory. I thought that was a pretty nice touch. So moving beyond the construction of the machine, the function also has several pros. The first one, and the biggest one for me, is the bit setter. So I was really sick of having to constantly re-zero Z between tool changes, and this bit setter, which is right here, completely does away with that. So between tool changes, the machine will measure the new tool's length, and you can also see how this works when you zero the machine. So if I hit 0Z here, it's going to go through and do a tool measurement, and this is very similar to how it looks when you're switching tools in a program. So it just comes over, touches off on the tool, and goes back. It's seamless, it's really easy, and I'm a huge fan. And back it goes. I also really like the VFD. As I said previously, I paid extra for the package that comes from Carbide 3D. They supply the whole thing for something to the tune of $1,200. You could get it all for less if you were to buy everything a la carte from China, Amazon, however you want. I like how it's powerful. 2.2 kilowatts at a fairly high efficiency is more than you're going to get with some DeWalt 120 volt router, for example. I like how you can set the RPM from your program and have it change on the fly. You don't have to fiddle around with some dial up here and hope you're getting it right. It's all automatic. And then the cooling system that Carbide provides is a chiller, which I have down here under my table. And it's not a refrigeration system, but it is a proper cooling system. So a lot of VFDs I see people using, they'll just use a 5-gallon bucket with like a pond or a fish tank pump, which is not the way, that's wrong. You're not cooling anything when you do that. You're just moving heat from the spindle to the bucket, and eventually it's going to get hot. This system is basically just a pump and a radiator, just like your car would be, and it actually is cooling the system and dissipating all the heat to the air. So I like that they provided that. I like that the spindle uses real collets. It uses ER32 or ER20 collets, so you can buy those in any size you want, from cheap to expensive. You can do it however you best see fit. The dust boot, which you can get in machines other than Carbide 3D, but this is the first proper dust boot I've had, and they've been awesome. So Carbide gives you one with some brushes here, which works best because the brushes are basically creating a seal all the time. Then they also give you one that is completely clear so you can see what you're cutting. I end up using the one with the brushes more just because it works better, and overall I have very little mess when I'm cutting, and I really appreciate that. The Carbide that runs them, or the software that runs the machine, Carbide Motion, it's good, it's decent. It could be better. I know it's like there's a very high bar to compare it to if you want to look at like industrial CNC machines. So in the consumer world, I think it is good. One nice feature worth noting that I appreciate is the software warns you if your program goes beyond the extents of the machine's capacity, so you aren't going to just suddenly get an error if you made a mistake in your program. The work holding, which isn't strictly related to this machine specifically, but more Carbide 3D in general, has been really good. I was initially skeptical of these plastic clamps that come with the machine, but I did end up buying the kit with more of the plastic clamps. I also bought their metal, I believe they're called Tiger Claw clamps. The plastic ones so far have actually been really good, and because you have a ton of them and they're cheap, you can put them wherever you want. They're actually fairly rigid, and I love how, being plastic, if you mess up and you hit one, you just cut right through it and it's no big deal. So overall, huge fan of the work holding. I have really not been using the metal clamps because they haven't been necessary, and I've been taking some pretty aggressive cuts. So last thing on usability, I really like how Carbide, it seems like Carbide genuinely wants you to have a good time and a frustration-free time using the machine. So they provide a bunch of things for you to make sure you have what you need to be using the machine efficiently. One example is a 30mm wrench, which you need to change collets on the spindle. So a 30mm wrench is probably not going to be standard in most people's toolkits, but they give it to you along with a bunch of extra niceties, and they've really come in handy when I just don't have something. I can just go grab it from the toolbox and keep going. So there's going to be some cons to the machine as well, and the first one for me, it's the biggest literally, but it's actually not the biggest deal in practice. It's the hybrid table. So there's two issues with it for me. Number one is that it's just not that rigid. So I wish I would have known this before I bought the machine, but when you press on it, it's difficult to see in a video, it moves. Had I known that, I would have built my table that it's setting on a bit differently so that I could secure it down in multiple places and make sure that it was more rigid, but I didn't. And now when you make a heavy Z cut, for example, you can see that there is a small amount of compliance there, and that's just really a bummer. I don't know if there's much I can do about it now. It is the way it is. The second thing is that there's no alignment features on the table so that you can get both Y-axis extrusions to be perfectly parallel and positioned properly relative to one another. It's a bit surprising because all of the machined aluminum pieces do have alignment features. I just would have liked to have seen maybe an X jig, an X-style jig, for example, to make sure that both of these extrusions are set up in the correct positions relative to each other and perfectly parallel. Another con that it's actually not Carbide's thing, but the dust cyclone I bought from them, which I have down here underneath my table, it's the mullet cyclone. It works. Maybe this is just a feature of dust cyclones in general. It's the first one I've had, but it captures a lot of the big debris, but not really the fine particulate. So I find myself having to switch out my shop vac filter before I have to empty the cyclone, which kind of negates the purpose of it. I just might as well empty the shop vac every time, but I'm still using it. It does work. The software, Carbide software, so Carbide Motion, I feel like it could be a lot better. I know there's like an infinitely high standard you could hold it to if you're comparing it to industrial CNC controllers. I just think there's a few small nuances that could be better. One of them is the speed limitation. So it limits you to 200 inches per second, and I believe 250, it might not even be 250 while cutting. And I think that's mostly a software thing. I do believe these steppers could go quite a bit faster. I just wish, they say it's for safety, I wish you could check a box saying like I agree to the conditions or whatever. I just want to be able to go faster, both when I'm setting up, jogging around, and when I'm actually cutting. The gas spring that holds up the 80 millimeter spindle, they say you need this so that the spindle doesn't fall when you turn the power off, and that's true. It does serve that purpose. But gas springs aren't really designed to be used in a dynamic system like this. They're made to hold car rear ends and cabinets up. So they have like a shock feature in them that kind of fights the motion that your servos are trying, or steppers are trying to put out. And I actually had an issue with my gas spring where it was causing the Z-home, it was causing the machine to lose Z-home because it would interact oddly at the stepper at max stroke. I did get a new shock or a new gas spring from Carbide. They sent me a new one free, and that did fix the problem. I just think that they could have used a bigger stepper with a lower lead ball screw or something to get rid of that problem and improve it while in the process. Even though I said I really like the spindle mounts, and I think since they are machined aluminum, I think they could have gone one step further and added in some tramming features, so some jack bolts, for example, so that you could tram your spindle to your table easier. With the alignment features and all the machined aluminum plates, I was able to get mine trammed in pretty well. I just think, again, for a fairly minimal additional add, they could have done that. The rigidity on the machine, it could be better. I know that it could always be better, right? Even on $1 million CNC, it could be better. I just think specifically on the X-axis extrusion, the torsional rigidity could be a bit better. So in the middle of this, when the spindle's in the middle of the X-axis beam there, you're gonna have quite a bit of torque being applied to that extrusion. And I think had they just made it a little bit bigger, torsional rigidity is a factor of the cube of your XY size on your rectangular cross section. They could have done a lot with rigidity there. I also think a bit more Z-axis clearance would have gone a long way. That's a direct contradiction to saying I want it to be more rigid. But right now it's something to the tune of 4 inches. Let's see what it's actually at here. It's 120 millimeters. 1 more inch or so I think would have gone a long way. All right, so on my last engineer's review, I talked a lot about upgrades I had done to my Millwright CNC power route, and those were mostly out of necessity because the machine just frankly wasn't very good out of the box. I haven't done a whole lot of upgrades to this machine, but I have done a few, and there's also several that I'm thinking about for the future I want to go over. So the first one is really what seems like not that big of a deal, but for me, it makes a big difference in quality of life. I have a shop vac hooked up to my dust collection system here under my table, and having to constantly bend down and flip that switch and forgetting to do so, back up, back down, it just becomes kind of a pain over time. So I put in a switch that outlet is hooked up to. So now my shop vac's on switch, and it's a nice quality of life improvement. The Y-axis E-chains here are able to fall off of their spot, and I think Carbide could have done a better job with that. They did put tapped holes along the entire Y-axis extrusions, so just putting a piece of polycarbonate here, some printed tabs, I think would keep those from falling out. That'd be pretty easy to do. Something that industrial CNC machines have that would be really cool would be a real-time power meter and spindle load indicator. So a load indicator would be pretty difficult to set up. You'd need strain gauges and some software to deal with those, so I don't think that's worth it. But a power meter, I think, would be fairly simple. I'm picturing adding an amp clamp somewhere in the 240 volt supply, and then you can just have a readout of your current spindle amp draw, and that would just give you a good general idea of how far or how close relative to max power draw you are and how hard you're pushing the machine, and that could let you maximize things and optimize your cutting a little bit better. Last thing, it's not so much of a future thing I'm going to do or actually an upgrade, but more of a recommendation, and something I did do is put everything you can on 240 volts. So because this spindle is 240 volts, I had to put a 240 volt circuit in here anyways, and I also hooked up the chiller to 240 volts. I wish I had a 240 volt shop vac, but it's kind of stating the obvious here, but double the voltage, you need half the amp, so your electrical distribution system is better, more efficient all around, and you need fewer wires, it's cheaper. So yeah, everything you can put it on 240 volts. All right, so I said I want a power meter so that I can push the limits of the machine and optimize my cutting. So speaking of that, the last thing we're gonna do is do some cutting demos to show you how fast I've pushed the machine and how hard I've pushed it. I have broken quite a few tools, and as I said multiple times, I am generally trying to cut as fast as I can. I have limited time to do these projects, so when I am doing them, I want to be as productive as possible. So I feel like I've gotten pretty close to the machine, the limits of the machine, and several different materials. So I'm going to do a demo with Acetal, which is also known as Delrin, Baltic Birch, and then some aluminum as well. Contrary to my previous review, I am trying to not cut aluminum with this machine, actually, just because it makes such a mess. I do have a little mini low profile vise here for small aluminum parts that I make from time to time, which leads to a manageable mess. And this little low profile vise isn't precise by any means, but it does a pretty decent job when you're just trying to make small parts. All right, thanks for watching. Stay tuned for episode 3. I really hope it takes me less than the 4 years it took between episode 1 and 2 to get episode 3 out.